Have you ever just stopped to look at a truly exceptional, highly rated bottle of wine and found yourself wondering about the actual dirt it came from? Because there is this absolute mind-bending paradox sitting right at the heart of terroir. Think about it. Why is it that vines forced to grow in the most brutal, rocky, unforgiving terrain imaginable consistently produce the world's absolute best, most complex elixirs? It's wild when you contrast the two. On one hand, you have these incredibly nutrient-poor rock soils that give us these world-class legendary wines. And then on the other hand, you have pampered, highly fertile valleys with deep, easy-to-grow-in soils, and they often yield just incredibly boring, unremarkable fruit. It completely defies standard agricultural logic, right? You'd think an easier life means a better product. But the secret differentiator here isn't the amount of sunlight hitting the leaves, it's not the amount of water they're getting. It is a hidden, entirely invisible biological reaction to the physical earth itself. We are talking about a reaction to something happening so deep underground that we can't even see it. So, welcome to this explainer. Today we are breaking down a fascinating source document titled Viticultural Resonances. And I am just incredibly excited to share this with you because we are going to uncover a reality that is honestly going to blow your mind. Grapevines are not just sitting there passively in the dirt waiting for rain. They are actually listening, literally listening to the seismic vibrations of the earth itself. So let's dive right into this. Over the next few minutes, we're going to take a journey through 4 main areas. First, we'll look at the mystery of terroir. Second, we'll explore roots as seismic sensors. Third, we're going to talk about the silent soil crisis. And finally, we'll wrap up with tuning the future vineyard. All right, let's kick things off with Chapter 1, the mystery of terroir, and what we call the paradox of stress. So the fundamental mystery of viticulture really comes down to how a plant perceives and then reacts to extremely subtle, repetitive geological shifts. The earth beneath our feet is constantly humming with tectonic energy. Now, to understand how a plant deals with this, think about professional athletes training at high altitude. When an athlete goes way up into the mountains, their body instantly senses that the air is thin. It's a stressful environment. So their body reacts by boosting hemoglobin production to capture way more oxygen. Well, the grapevine does the exact same thing with this subterranean hum. It detects the microscopic vibrations of the rocky earth around its roots, interprets that physical instability as a threat, and prepares for battle. It literally builds biochemical armor. Instead of just lazily growing big leaves, it shifts gears and pours all its energy into producing incredibly complex defensive compounds. Which brings us perfectly into Chapter 2, Roots as Seismic Sensors. This is the Earth's hidden symphony. It turns out that the common grapevine, Vitis vinifera, isn't just a plant. It acts as a high-fidelity biological sensor that is deeply embedded right into the Earth's crust. And this introduces a really crucial scientific concept called mechanotransduction. Now, I know that sounds like a mouthful, but it's actually super intuitive. This is simply the process where roots act as seismic transducers. They're converting localized geological noise into electrochemical signals. I really want you to absorb that for a second. The root hair cells down in the dark, they aren't just little straws blindly drinking up water and minerals. They're actually feeling the kinetic rhythm of their specific geography. They're translating the physical movement of the earth itself into usable chemical data. To picture how this actually works underground, imagine a guitar string being struck by a tuning fork. When you strike that fork, the string nearby naturally begins to vibrate in sympathy, right? Well, the soil essentially acts as this massive resonant chamber. Depending on the mineral density down there, like whether it's heavy damp clay or solid echoing limestone, the earth amplifies very specific low-frequency waves. And the vine's roots detect these mechanical waves traveling through the soil particles, vibrating in sympathy exactly like that guitar string. Here is another way to look at it. Picture a sprawling underground subway station full of sluggish commuters just kind of randomly walking around. These commuters represent the nutrient ions inside the plant. If the station is quiet, they just wander aimlessly. But suddenly, a low-frequency hum starts pulsing through the concrete platform. A train is coming. Instantly, all those commuters align. They start moving with intense purpose and urgency toward the exits. The vine's vascular system does exactly this. When that seismic resonance hits the roots, it physically organizes the flow of water and nutrients, rushing them up toward the grape bunches with incredible speed and absolute specificity. Okay, let's break this entire reaction sequence down into 4 really clear steps. First, the soil transmits a low-frequency wave, which is amplified by the local rocks. Second, the vine's roots detect this kinetic energy through that process of mechanotransduction we talked about. Third, and this is honestly the magic part, this detection actually triggers specific gene transcription inside the plant's DNA. The physical hum of the earth literally flips genetic switches. It's wild. And then fourth, this genetic trigger causes secondary metabolites to just flood the skin of the grapes. The plant is completely calibrating its ripening process entirely to the physical vibration of the ground beneath it. And all of this leads us to a term called phenolic plasticity. Basically, this is the vine's ability to direct defensive flavonoids and polyphenols straight into the berry skins. It acts as an insurance policy against that vibrational stress. When the vine feels that subterranean hum and assumes it's in danger, it actively pumps these compounds into the skin to serve as a natural sunscreen and a defense system. But here is the kicker for us humans sitting at the dinner table. These defensive compounds are the exact same things that undergo complex oxidative polymerization during the winemaking process. They are the things that provide the deep texture, the rich color, and that lingering mouthfeel that we immediately recognize when we taste a truly exceptional, high-quality wine. To really visualize how these compounds work, imagine chewing a normal piece of bubblegum. The polymers inside are short and disconnected, right? If you try to stretch it, it gets thin and snaps easily. That's exactly what happens in a pampered, unstressed vine. You get flimsy, flabby wine. But if you were to weave those same bubblegum molecules together into a tight, complex web, which is exactly what seismic stress forces the grape wine to do with its phenolic compounds, the material becomes incredibly tough and resilient. Those seismically woven molecular webs are what give the final wine its density, its profound structure, and that remarkable ability to age gracefully in a dark cellar for decades. Which brings us to a much more serious topic in Chapter 3, the silent soil crisis. Let's talk about what happens when the earth goes quiet. So this incredibly delicate acoustic system is currently under massive threat from a major antagonist, and that is climate change. As global temperatures rise and our weather patterns shift, the amount of moisture held in the soil is drastically changing, and this severely alters the subterranean resonant frequency. Think about an old-school radio trying to tune into a distant music station during a really violent thunderstorm. All you get is loud, aggressive static, and the beautiful music is totally lost. Well, water happens to be an excellent conductor of seismic waves. When a region suffers from severe drought, the lack of moisture creates massive acoustic static. It dampens everything. The soil can no longer transmit those crucial low-frequency signals, which leaves the vines completely acoustically deaf to the Earth's rhythm. They never get the signal to build their chemical defenses, and the result is a thin, characterless harvest. Now, to measure exactly what is being lost during these droughts, scientists look at something called the proteomic profile. This is the specific mapping of defense-oriented enzymes within the grape skin, which are synthesized in response to the historical vibrational data of a specific site. This is actually exactly why the world's most famous Grand Cru vineyards have stayed globally superior for centuries. It is not magic, it is straight-up geomorphology. Their soils are packed with crystalline quartz or volcanic basalt, which act as massive natural resonators. They are structurally superior acoustic environments that lock those specific vines into a higher metabolic gear year after year after year. To understand the proteomic profile in action, imagine a massive, quiet library where everything is neatly organized on the shelves. Suddenly, an earthquake hits. The floor shakes violently. The librarians, who represent the vine's internal signaling system, start to panic. They sprint around the aisles, pulling every single vital reference book off the shelves and throwing them onto the tables so they can be used immediately for survival. The proteomic profile of the vine works exactly like this. It feels that vibrational danger and just mass mobilizes its biological books, its defense enzymes, pushing them all directly into the fruit to protect its offspring at absolutely all costs. And that leads us to our final chapter. Chapter 4, Tuning the Future Vineyard, the Conductors of the Crust.
So, the big question is, how do we save this ancient process in a rapidly changing climate? Well, we are entering an era of literally sci-fi level precision geophysics, known as precision viticulture. And the tools they're deploying out in the fields are absolutely staggering. First off, farmers are burying fiber optic seismic sensors deep in the root zones. Second, they're actively monitoring frequency responses in real time, essentially listening to the entire vineyard's acoustic health on a dashboard. And third, and this is the part that just blows my mind, if the earth goes quiet from a drought, they're installing piezoelectric transducers directly into the dirt to actively mimic natural seismic rhythms. They're artificially retuning the vines back to their optimal metabolic state.
The modern viticulturist is no longer just a farmer out there with a tractor. They are practically a geophysicist. It is exactly like a master conductor leading a massive symphony orchestra. But instead of waving a wooden baton, this conductor uses a subtle, high-frequency subterranean pulse. If the vineyard's violin section is playing too quietly, meaning the vines just aren't producing enough of those crucial phenolics, the farmer increases the acoustic pulse in the soil to signal more intensity. They actively adjust the physical, vibrational input to perfectly balance the biochemical output of the plants. Which brings us to this incredibly profound conclusion from the source material. It says, we must cease viewing the vineyard as a static landscape and start viewing it as a dynamic, reactive system of mechanical and biological exchange. I really want you to think about that for a second. The soil is not just a passive bucket of nutrients that we dump water into. It is an active, humming medium for acoustic communication between the earth and the biology that draws life from it. So I want to leave you with this final mind-bending question. Are we actually ready to actively curate the dialogue of the Earth's crust? By fusing geophysics with biochemistry, we finally have the technological power to protect the delicate chemical fingerprints of our greatest agricultural sites, ensuring they survive for generations to come. It completely changes how we view every plant, every field, and literally every tremor of the earth beneath our feet. Thank you so much for joining me on this explainer. I really hope this completely changed how you see the ground you walk on. Keep questioning, keep learning, and I'll see you in the next one.